We're going to look further at a particular type of indices, okay, where the numbers are given the power of half. In other words, they are all square roots. However, these numbers cannot be square rooted because they are not perfect squares, and hence this gives rise to irrational numbers. Okay. However, to work with these numbers, which are called surds, we make use of two main rules. Okay, they are from the law of indices, and the first rule is that square root a times square root b is equals to square root a times b. Okay. We can also look at it the other way around. If I have square root a times b, I can break it up or split it up into square root a times square root b. Similarly, if I can look at square root a over b as square root a divided by square root b. Okay, we should make use of these two here. Okay, in this example, simplify square root 50 plus square root 72 plus square root 160 divided by 5. The main strategy to simplify surds without the use of a calculator is to first re-express the numbers in terms of its prime factors. Okay, so let's see. Square root 50. Okay, square root 50 can be written as 2 times 5 squared, whereas 72, okay, 72 can be written as square root, okay, let's see, 72 can be written as 2 times 6 squared, but 6 is equals to 2 times 3, so I get 2 to the power of 3 times 3 squared. Okay, in other words, I have 3 squared times 2 cubed. 160. Now 160 can be written as 16 times 10, right? But 16 is actually 2 to the power of 4 times 2 times 5. Okay, in other words, I have 2 to the power of 5 times 5. And last but not least, we have 5. Well, since 5 is prime, we can't do anything to it. Okay, so what do we do with these numbers then? So remember from our first rule, okay, I can split up a surd into two parts. So when I split this up, I get square root 2 times square root 5 squared plus square root 3 squared times square root 2 cubed plus square root 2 to the power of 5 times square root 5 divided by square root 5. Okay. Now, for the second part, even if we don't break it up and we write it like this, okay, we notice that this is from the second one, right? We can rewrite it as a fraction like this. So for the second one, you could immediately write it as square root 2 to the power of 5 times 5 over 5. Let's simplify the first term. Okay, square root 5 squared, square root of a perfect square, give back the number itself, so I get 5 square root 2. Square root 3 squared is 3. Now this square root of 2 cubed, we can look at 2 cubed as square root 2 squared times 2, right? Which is equals to 2 square root 2. So I rewrite this as 2 square root 2. For the last term, notice that this is a 5 and a 5, which is common, okay, in the numerator and the denominator, so I can cancel it out. I'm left with square root 2 to the power of 5. Okay, simplifying a little, I get this. 2 to the power of 5 can be rewritten as 2 to the power of 4 times 2. So again, I apply my rule here. Alright, this actually becomes square root to the power of 4 times square root 2, which is 2 squared times square root 2. So I get plus 4 square root 2. So I get, eventually I just take the sum of 5, 6 and 4, okay, to get 15 square root 2. Let's look at a second example. In this case, I want to simplify a fraction which consists of surds in both the numerator and denominator. And when we want to do this, we normally try to get rid of the surd in the denominator. This will help us manage it better so that I can use it for further calculations. Okay, it's harder to work with surds in the denominator. So in order to simplify this, we are banking an idea, okay, of multiplying both the numerator and the denominator, okay, by what seems to be like the denominator, but by changing the sign, okay, by reversing the sign. So if this is negative, I use a positive sign here. Why? Well, we are banking on this rule for expansion. A minus b times a plus b is equals to a squared minus b squared. In this case, a is just my 3 root 3 and b is my 2 root 2. And we introduce the a plus b term here. So if I have a minus b times a plus b, I get a squared. Okay, in this case, a squared is 3 square root 3 squared, and b squared is 2 square root 2 squared. Okay, which ends up with 3 squared times 3, 3 cubed, 2 squared times 2, 2 cubed. So let's work this out. In the numerator, we can't do much first. Okay, let's just keep it this way as a product. In the numerator, we get 3 cubed minus 2 cubed. So for the numerator, all we can do now is to try and expand things out. So I get, okay, 4 root 3 times 3 root 3 gives me 12 times 3. 4 root 3 times 2 root 2 gives me 8 root 6. Square root 2 times 3 root 3 gives me 3 root 6. And last but not least, 2 times 2 root 2 gives me 2 times 2, 4. Okay, and then the bottom I get 27 minus 8. Okay. Once I simplify this, I'll get 40 plus 11 root 6 over 19. And this is the final answer. I can't simplify it any further. So this method of multiplying what we call the conjugate, okay, on the numerator and the denominator, okay, this technique is called rationalizing the denominator of the fraction which contains a surd.